Hello, everybody. My name is Shyngys. I'm Ethereum data analytic, data scientist, smart contract programmer, whatever you call me. Mostly work on EVM compatible chains. Happily, right now I'm grateful for it. I was considering to move to Solana or other chains, but after seeing this FTX crash, I'm good. I'm good for now. I just want to stay here. I'm liking Ethereum ecosystem so far. I'm most familiar with it. And today we will cover some programming basic terminology for entry people, or you just want to have a concept. You have a theory, but you want to see how it's applied there, right? So let's dive in. By the way, if you want to see like more of this content, you can subscribe to my Telegram channel. It's here, right? I put it here. Yep, block hacks. I cover some blockchain hacking, like news, some coding behind it, or like how the validators gave up their private key, or how this bridge becomes so vulnerable, or maybe alerting you from from my audit, from my personal audit, like, oh guys, don't invest in this bridge. Not like financial advice, but more like technical advice, or commenting on the technical durability of the projects. So let's dive in. Uh, yep, we'll be moving to, uh, so yeah, let me put myself here. Um, you see the content here? Oh, yep, here. Uh, we have this halving, then we have consensus. Halving in terms of the Bitcoin, the consensus means like proof of stake, proof of work, delegated proof of stake, which is on Ethereum and Cardano and Tron. Then we have this stashing. Basically, when you misbehave in the proof of stake network, you get punished. Like in Bitcoin, if you do something sketchy, if you try to bamboozle the network, you get nothing. You will not even get kicked out of the network. You just stay there, like, oh, sorry guys, I'll not do it again. You don't have to even promise that you will not do it again. You just keep going. Nothing happens. Um, which happened to, like, not BTC, but its forks like Vertcoin many times. Attackers took over the blockchain. Basically, they had many botnets and they just mine it, and they did double spending and many types of attacks. Um, Also, yeah, by the way, this is the content, but if you want something like, something to cover else, let me know. Like, personally, I will cover it for you and make the next part, of this. Uh, so yeah, next one is how the same EVM becomes faster. So like we have Phantom, we have Tron, which is kind of EVM, but they call it TVM. Um, or let's say how even Cardano, why Charles Hoskinson he like left Ethereum and started his own Cardano, and why it's faster in terms of programming. Uh, how sharding works, and like some people say it doesn't work, so we dive in the technical aspect why it doesn't work, and also how smart contracts that we know, like Uniswap contract, NFTs, tokens, all of these are smart contracts, how they're placed on ETH in terms of programming, and why they cannot be on Bitcoin, why we cannot do Uniswap on Bitcoin, so we don't have to go to Binance or like exchange, centralized exchange, basically. Let's dive in. Here we go. First of all, the halving. Let me place myself here. Yep. So we know that it's basically a historical event every time the price jumps up after it, and we have this 200, like basically this amount of blocks, like mine it, so the halving happens. And it's expected to be every 4 years or something, and it's not finishing soon. Even if this century, it will be in this next century, and it's not clear yet what will happen after this. After this, everything is mined. Uh, from halving, we can see that It's mostly for like the definitive supply chains like Bitcoin, Cardano. They have this. Oh, Cardano doesn't have halving, but Bitcoin they have halving to i- kind of increase the price and limit the rewards. Well, you know the economics better than me. Why? Let's dive into coding. So here is the code of the Bitcoin. It's written in C++, if you're familiar with it. So we have this here, C amount get block subsidy. C amount is just C amount is like what should we return? You know, like it returns amount of uh mining reward. So the get block subsidy is like how how much we get from block. So the network subsidizes your efforts to mine the blockchain, right? Actually, your result of mining blockchain. So the height is just what at what so blocks, and what height we reached so far. Um, consensus parameter is just ignore it. So we have this first line. It's called. Let me dive in here. Here, yep, halvings. You see here is equal to something. We will dive into next slide. So you see here as well. Yep, this one. Uh, C amount and subsidy 50 coin. Yep, remember this line. We will dive in. Yep. So here, um, subsidy halving interval. It's what we set. So Bitcoin creator Satoshi Nakamoto set it to 210,000. But let's say Litecoin, it sets like it just multiplies to 4, and right now they have more halving and more inflation, or something like that. I can copy this, fork it, and place my own halving interval. There is nothing that can stop me. But the thing is, people will not move, right? People will not see value in my coin. Miners will not come, and they will not decentralize my coin. So that's a problem. And we see here we have this amount of blocks. It's 600, basically 63 divided by 21. 63 is just the height of the block right now, and it's updated constantly. I just put it as an example, and that's it. That's all we have, right? That's just how forking works. And in the initial era of Bitcoin, they literally did the same. Bitcoin Cash, Satoshi Vision, Litecoin, Bitcoin Gold, name so many OG coins. They all did the same. They didn't innovate something actually, except Ethereum, I guess. Yep. So this is the next one. It's about the slashing, the validators. Uh, you might recognize this is Python, and we can see here. Um, this is the backend chain. Yep. Yep. Backend chain. So we know that it's Ethereum 2.0. Slashed index is the validator index. So what's the index? It's basically we have this order of validators like 0, 1, 2, 3, 4, 5. Like let's say 0 is Jimmy from California. 1 is let's say somebody from Shanghai. Second one is somebody from Texas. Uh, so when we want to slash somebody, we say, okay, we don't refer to him as Jimmy or address or something. We just say index, like 0, 1, 2, 3. We just pick up and say, okay, this guy is a bad guy. Slash him. We say first guy. Okay, we take him. So here we go. The epoch. It just. Oh, sorry. Yep. Oops. The epoch here is just time right now. The initiate validator exit. It's the way to kick out the basically to kick out the suspicious validator. It could be anybody else who's acting against the consensus. We can see he has a validator, the state of the current chain, like what's happening, what's the state of the chain, and the slash index, basically the index of the validator. We can see the validator is equal to state that validators. Basically, we're just picking up who is the validator, like, and we're saying we're attaching a label like, okay, he slashed forever this address with all his history, all his balance is slashed. Then we say validator that withdrawal epoch is, we're just saying he can never withdraw his money, like period, to withdraw his stake. It's gone, it's never. And we say state slashings. We're just saying like we have, so we have the slashings, stored slashings. We just increasing it with the new validator. We're saying, okay, slash guys, here is the new guy. Welcome him. Then we say slashing penalty. So we're just saying like we'll just keep getting all his balance. You see, there is no like balance divided by two, balance minus 5% or something. Just literally taking everything here. Like here, yep, you see here, right? Yep, yeah, effective balance. Then we have this decrease balance. So we're just saying, okay, we take froze all his money, mine, like we took all away his stake, we penalty him, and now we're just gonna decrease his balance, disappear, nothing happens. uh he has nothing left. Then we say somebody has to propose that he's suspicious, right? So we say, okay, this was a proposal, let's get this index, and let's, who posed it, he's a whistleblower, he's a good guy, let's clap him, and let's reward him. It's basically here. Yep, here we just say, okay, we're rewarding him, and we're rewarding him with the guy with the amount that we slashed. So yeah, basically we are increasing his balance later, the whistleblower balance. That's it. Uh, so it's, there is one thing I don't like. Like, I'm bullish on Ethereum. Okay, I'm like, I really like it, the ecosystem, everything so far. But what I don't like in proof of stake consensus is that, let's say in Bitcoin or proof of work, just generally, I mine my hardware, and if the network gets somehow rigged, like, we have still hardware, right? But let's say in the proof of stake, the main guy, he can say one day, okay, the other guys, they don't have a stake, they have zero stake. I'm only a guy who has everything, and he can just take away the network. Of course, it will not happen, like, because they can stake and hard fork. I mean, the hard fork anytime, the adequate validators. But it's just so vulnerable at this point. Yeah, it makes me a little bit disappointed. Um, but I hope it could be solved soon. I might propose something as well. I need to propose. Uh, so yep, we covered this. Yeah, and what about this one? So why some chains are faster? You might ask, right? You might see these pitch decks, like if you're an investor, you get like lots of pitch decks, like, okay, where we will process 100,000 transactions, or like we battle tested this much and that much, right? So they might be because of the language they use, first of all, because every blockchain use their own language. Like, I think Ethereum used something before, but now they're using like Go, I guess, and the Bitcoin is using C++, and it's not even optimized like the C++ code there. So, and yeah, optimize as well. Like, we have this optimization techniques, right? So uh, if the blockchain is using the fast compilation to process, to validate the transactions and everything, then yeah, it will be faster, of course, like naturally. And if the code is optimized, it's written by top experts, then for sure there's it will be top tier. Yeah, we can see the list here. Oh, yep. And we also can see this funny fact is that the machine that's running on, like, if the validators are running on Linux, then they will be fasting. They will proceed the transaction faster, means the chain will be faster compared to the Windows guys. So, you know, the detail here like is important as well. Uh, so we can see the fastest ones. So the energy means how much like electricity they used, kind of. We can see Rust, which is the mainstream for like the new trend for these blockchains, is like the top. And we can see the time is Rust is also good. And you can see the Java here as well, the top. It's used in TRON. And we can see the the uh, the megabytes, which is the memory, which is the blockchain memory, basically. Like, if we use something lightweight, our blockchain will not be so heavy over time. Like 200 gigabyte, 400 gigabyte, it doesn't matter, but it exponentially gets bigger and bigger, and not affordable for people. So yeah, let's see this one. Oh yeah, so if you see those labels like we're fast, you should question them. And also it shouldn't be the selling point anymore. You shouldn't like, okay, it's fast, throw all your money, It's not a selling point anymore. We have so many chains, so many things out there. Like, why would okay, you're fast, but you should offer something unique, You should adapt to the market. You should be competitive. So yeah, regarding the questions, you should say whether they are battle tested, whether they conducted the speed test several times in different environments, and is it possible for us to reproduce it? Because if they conducted once under some unknown conditions, I can't trust them. And well, if you didn't conduct it, well, then who knows? Like it's like Titanic, right? They say, the ship will never sink, but it might go sink, right? So the battle test is a key here, no matter what. And we should ask how many validators or RPC nodes they have now. I'll dive into the next slide uh, about some interesting chain, and also look. Well, uh, here's the interesting thing. I'm a blockchain developer. When I go to invest to some project, I don't ask like, oh my God, can I see the white paper? Or like, oh, who's backed by which VC is backing it? And like, what's the lock period? I mean, of course I ask those, but I ask like, how can I mine this? Do you need validators? I have this, hardware. I want to mine this. And if they ignore me or they avoid, or if I see their mining documentation is not really clear or is somehow centralized, then, I'm gonna say like maybe bye bye. Because man, come on, it's a decentralization. Like, why would you hide some information about it? Uh, yeah, that's what I don't like generally. I had many cases like that. For example, there was a project called Max Finance. It's Max, it's like a really fancy name, but when you just like in the Telegram chat, you just ask like, guys, how to mine this coin, how to become validator, and they're gonna say bye bye to you. To you, like it's so rude. Like I just see it so cocky, Uh, yeah, okay. So yeah, what about the mining software? For example, there is a project called Mimic. They claim to be, Bitcoin replacer. Their UI UX is good, but go to their mining like pools, go to their website and try to run it. It's dead. You cannot run the software. It's somehow very complicated to set up a node. So that's a huge red flag for me as a developer. Yeah, and also see the minimum validated requirements. If it runs on the small old laptop and it can proceed fast transactions, then it's good. But if it's like saying like, you have to have an IBM machine, then you can become a validator, then of course it will be fast. Of course, even if it's written in slow language, it will be fast because it's IBM machine, you know. Here the but here yeah here the requirements you can compare. Here I think the Polkadot requires some high CPU and well yeah Solana is kind of like requiring high memory. I see here yeah. Uh, okay. So the next one is oh yeah it's Polygon. We can see here. So it's from Pixel Packs. Um, I borrowed from them. Thanks, guys. So you can see, ignore this market cap, everything, okay? You know better than me this information. Just look at the scalability part. We know Ethereum, it's kind of slow, expensive, and Polygon, wow, it's so cheap. Let's develop there. So many grants, Disney partnership, right? And we see this 65,000 TPS. It's so great. Wow. Like I'm gonna grab some Matic, you know, I'm gonna be a Matic whale, but Matic whales are dumping on you. So let's see the shocking truth maybe for you. It's that they have only 100 validators, like the like 100 only. Like you can check, you can go and check it. And so many people were complaining about it. And of course, with 100 validators, it will be very fast. You can just like grab those people at the chair and have a quick talk and say, guys, can you censor one guy or like, can you guys upgrade your hardware? You know, like please something, right? So, and what's shocking is that last block is produced by one validator. Just go to Polygon scan, okay? Right now you can go and check, put the guy, like the last guy who mined it, and by Control F you can see like how many people, how many blocks that guy mined. So that's kind of a red flag. I mean, they don't claim to be decentralized. At least they just claim to be fast, and they have so many partnerships. And they launched this side chains called like Polygon Super Chain. Uh, but yeah, at least they don't claim to be decentralized, right? So they're not lying technically. But like they never told you that. So up to you. So so the next part is it comes to the sharding, right? So here we see how sharding works. It's the sharding is not something innovative. It's not something that Ethereum only invented. And the blockchain itself is not innovative, right? It's been used like for a long time, even before Bitcoin, but it's just Bitcoin comes to be as a public blockchain. So here we see sharding. It's a fancy word. It's like a term to divide one data to separate parts. That's it. There is nothing hard. Like just imagine. Like I don't think I have to explain this deeply, right? It's just data split. What could go wrong is just the part like let's say you make a transaction, your transaction is stored here, and your friend make a transaction, your transaction is stored here, and let's say somebody transferred you money, so that's stored here. And what if one of the validators turned off their machine, or I don't know, they went bankrupt, or something happens, you know, something really un- unexpected? Then, well, man, your data is lost. So somehow we have to recover. So that's the only problem with sharding. But it could speed up some like processes because, as we said previously, Solana requires high memory, but it makes it unaffordable. You know, like people cannot just mine it because so much data. But with this sharding, people can like ease the cost of entry. You know, for my so it brings some decentralization. Yep. So here the so it won't work for Ethereum. I mean, I'm not claiming, it's not like bold claim, but it might not work for Ethereum due to the fact that uh, you know, it's hard to. like we have this tons of data, and it's hard to like make them compatible to this kind of database type. It's possible, but like really hard. It's like extra effort. And Polkadot is like, it supports this natively, so it's called Substrate. Even their framework is called Substrate. I don't think it's like coincidence. So they are perfect with it. They have so many short side chains right now. You can see because of this nature of Polkadot. Yeah. Regarding the smart contracts, we can see Bitcoin has smart contracts. It's called script. We can see in the pub script here, but it's just the store of value, store of assets. It's just the like, it's nothing but like Jimmy transferred to Sam or Alameda to FTX. That's it. It's not possible to like swapping ETH to USDT or like generating new NFT with metadata or like uh, I don't know, betting like who will win in Qatar, like something like that. It's not possible because it is not Turing complete. Uh, I respect this guy. He's a Turing. He's my favorite person who inspired me for programming. The Turing, it's not Turing complete means it's kind of like basically not complete. It's not designed to be that way. It's kind of safe in this way because you just have one function. Like it's like really foundational, and it's uh like like the yeah, it's just foundational. We need it anyway. Uh, we might need this decentralized betting or like decentralized swapping, but without transfer or store of value, it's all useless. Kinda. Uh, so what about the Ethereum? Here is the quick dive on how it works on Ethereum. Uh,
So here we can see the Ethereum smart contract. Compare it to C program, basically. Yep. So here we can see, oh, yeah, somewhere here. This is a Solidity, basically Solidity contract, smart contract to write a hello world, just the emitting event, nothing much. And you can see it's just a 366 bytes, while like the regular C++ like C program would cost us uh, 33 like thousand kilobytes, 33,000 kilobytes because it just compiles. So just imagine like why the Ethereum devs they invented this Solidity rather than the C. It's fast, yeah, but it's not memory optimized. Uh, so Solidity maybe it's not good option. It's maybe not so friendly, but out of those options we have, it's the most memory optimized, considered to be memory optimized. But if you have some suggestions, just let me know. So the next thing is here. Oh, here's just the topic that I want to cover on Merkle trees and Merkle proof of reserves. Basically, how it works. Here, basically, just a tree. You might know what's hashing. Hashing is like in like we provide some value, like one, and the hash becomes something random, and we provide our name or some password, then it becomes something random value. It's used in blocks. Google, Facebook, Microsoft, maybe they are storing our passwords using hashes. So, they we will not get expose our real passwords if hackers hack into it. Or let's say the developers, when they view the database, they don't see our real password, just a hash. Because when we enter the password, the website compiles the hash, then compares those hashes. If there is something different, let's say you write top, and then you write just top G, it's completely different. or you change the capital letter to something else, then something the hash will be completely different. So the Merkle tree is just the binary tree like this, completed of these hashes of each thing. And at the top we have the like final hash. Um, Sorry for using so many hashes. Yeah, basically, why this is useful. So in this way, we don't have to hash the whole file, or let's say we divide the project to the structures, and if there is one hash will be corrupted, then we know which part is corrupted here, instead of recompiling and trying to find and wasting time on everything. It's much more useful technique in Ethereum. Uh, so how it works in terms of reserves. Uh, we have this proof of assets, right? Like, for example, we ETT or Bitcoin, they have this sheet and they have these all addresses listed. We can check it, and they're usually over collateralized. And here, Binance, they also have their. But here's my concern. Let's say Binance, Kraken, all the way they have perfect uh, proof of reserves, right? Let's say they have 10 billion or $1 trillion there, but we don't know how much money users deposited so far. How much money is Binance liable to other companies, like proof of liabilities? So maybe they deposited $2 billion. The users deposit $2 billion, but Binance has only $1 billion. That's not, you know, then if people will pull out their money, then basically it's a bank run. So yeah, I wouldn't trust this, especially when they even with this proof of reserves, they just move their ETH around, their reserves around after the snapshot or before the snapshot. Like so many sketchy things happening right now. Uh, and yeah, this is the end of the slide, and just want to tell that well, Uh, it's been a harsh month with all of these events happening. But by the merge, I was hoping to expect some good news. But yeah, it's sad. But I'm at least glad that it wiped out some scam shitcoins, but only the strong ones left. I guess. So, but let's see what future brings us, and yeah, let's keep following the news. What's happening? Hope to see you in the next video.